So my name is Joanne Lindeque. I am the science teacher for grade 5s and 6s. And with me I have
Gillian Weldrick, and I am the science teacher for grade 7, 8s, and 9s, and then I teach physical science to the grade 10s at IVA.
And we are here to tell you all about our Science Week. So with doing our Science Week, we had a range of activities planned, and it was things like experiments, it was things like challenges, but it was also things like rocket launches, dissections, and having people come in to chat to our learners. So we did have experiences that were beyond that anything that's been done before. We had Anglo-American come and join us, and it was the first time they had ever done a virtual science experiment. So that was very exciting, and our learners absolutely loved Science Week. It was very interactive, and they really did engage with the activities that we had planned. So I'm going to start off with the senior primary. In the senior primary, we had a range of activities that kind of fitted into a whole different lot of aspects of science. So the first one is that we looked at friction. So my grade 6s, we are learning all about different forces, and we focused on friction during Science Week. And with that, we had some friction frog races, which I can actually show you here. So I had string, and my grade 6s had to climb their frogs all the way up to the top of the string, and we all did this virtually. So everyone had their strings ready, and we had to create friction, and then our frogs then climbed up. And it became a race in my class, and we had some awesome prizes up for grabs on that. Then in my grade 5 classes, we built rockets. It was so much fun. They had to use, again, different types of forces to get their rockets to launch. And we had the scientific process, so they had to do the design process. And then on the Friday, they had options where they could launch their rockets on 4 different occasions. And in between each, they had an option to modify their rockets. And then we could see who went the furthest. And then in the grade 4s, we focused on the moon. So the grade 4s had to go outside every single day to go and track where the moon was at and what was happening. So what phases of the moon we were in. And as a phase, we came together and we had chemical rocket launches, which was so much fun, besides for the fact that I was drenched in vinegar thereafter, and I'm sure Gillian will confirm, because right after being drenched in vinegar, I went through to her house so that we could have our Anglo-American experiment. So Gillian, tell me a bit about what happened in the high school during Science Week.
Yeah, so the grade 7s, they made some really smelly cabbage leaf indicator. So it comes out, we used this, the purple cabbage. So it came out this gorgeous deep purple. And then we used that cabbage leaf indicator to test household substances like ammonia and handy Andy and dishwashing liquid and drain cleaner and all sorts of things that we could, even tea and coffee. So for me, as a science teacher, that was quite exciting, because we very seldom get the chance to do that sort of thing in an in-person classroom. You know, the teacher will stand up with the chemicals and do the experiment. This time, students were able to do it in their home, and it was a good practical, because every child could do it. It was substances that they had available to them, and all they needed to purchase was a quarter of a cabbage, a red cabbage. So that was fantastic, and our grade 7s had a great interaction with science, with like real life science. It was fantastic. Then
tell me about this purple juice before we move on. I heard some stories about the purple juice, that it was left in the fridges too long and it got smelly and it stained. Parents must have loved you.
Yeah, they did. We had a discussion about this, the things that we leave around in our kitchens. Well, in particular, my kitchen. They were quite disgusted with what happens. And yes, the smelly juice was overwhelming. So that was like one of the observations, was the smelly juice. However, the smelly juice can turn color. So it changes color from this purple to the most incredible blue. So like the sapphire blue and emerald green and I was going to say pea yellow, but let's not go there. Let's rather say sunflower yellow. And pinks, like these brilliant pink colors. So it is such a great substance to use as an indicator because it gives you all these brilliant colors. So yes, some kids were like completely freaked out by the smell. And some just loved it. So it was great. It was a great experiment.
And what else happened in your phase during Science Week?
So grade 9s, in life science, we were discussing the circulatory system, and that's obviously all about the heart. And so I wanted to give students an opportunity to see a heart real life. It's also, again, it's like really tough to do that in person because you've got one teacher who is dissecting a heart and people can't really see because they're all around this heart, heads are in the way. So it was really fantastic to put it underneath a camera and to cut this heart open. And we saw the pericardium, the layer that covers the heart. We saw the ventricles and the atrium. And we were trying to discover which vessel was which, because there's so many that come out of the heart. So we were busy like sticking my finger through and seeing, okay, so it goes from that vessel through into this chamber. It was a great experience to see the mechanics of the heart, the physical mechanics, what it looks like, and the physicality and that rich fat muscle that makes our hearts go. So that was fabulous.
I know my grade 6s joined you, and the first thing was like, oh my goodness, it is not the shape of a heart. And I had to explain to them that a heart is not the same as the shape of a heart. And it was actually quite entertaining just to have like that exposure for them was just beyond this world. And one of them came to me and was like, so Miss Lindeque, I thought I was going to be a doctor. And then I sat through the dissection and I didn't enjoy it. And she was like, maybe I'm not going to be a doctor anymore. So I do think that like just learners having this idea of what is an organ and how does it function, it's very different to actually seeing, oh wait, there's this full-blown heart in front of me. And if I poke my finger through this hole, oh wait, look, it flows through the heart and things like that. So I know from our side that was such an awesome experience for the grade 6s that joined. And with that, we also had like the really cool experiment with the Anglo-American. Can you tell us a little bit more about that?
Ooh, yes, she was fab. I really enjoyed her. You know what it brought, especially for the older students, it brought a sense of how chemistry is so relevant in our industry. I mean, it's right up there. Anglo-American do this, and they do this on like a day-to-day basis. Extracting metals. It was the most incredible presentation. Yeah. So she did an electrowinning experiment. So we in the higher grades we know that is electrochemistry. So it's moving electricity through a solution of salts, and in the salt is the metal, and then the metal sort of sticks to one of these electrodes. So there are two metal pieces that sit in the solution, and they get covered with this metal. So it's like it's like metal plating, I suppose. So if you've got a chain that's gold plated, that's what would have happened. Your chain would have been coated with gold. So that was a really eye-opening and great for my senior students to see that, and that it's actually relevant. So the stuff you're learning at school is relevant.
And I know it must also give them like a lot more of, or a broader idea of what's out there in terms of industries in science and what you can do with science beyond school. I know that Anglo-American spends a lot of time in schools bringing up female science and just science in young girls and just showing them that there's this whole world of science, whether it's in chemical engineering or whether you want to become a full-blown scientist, there are these opportunities out there. And I think that was just such an awesome experience. And then we're still talking about Science Week. We ended off, I mean, you joined me, and we ended off at Sci Bono. And I mean, how incredible was that experience? We had over 40 students join us. We had a water show. We had a science show. We went into the NASA time capsule thing. We looked at periodic elements. We looked at a whole range of things. I mean, I think they even got me spinning in like a wheel to try and show motion. I mean, I did get some grass burn from that experience, but it was so much fun. I know you also shocked some students. We got everyone to hold hands, and we taught them how your body actually conducts electricity. And then, for me, one of the most fun things was watching the students go through the mirror maze. Yes. And just how optical illusions and how they use science to create this incredible maze that the learners, I mean, I had to go and fetch some learners out of the mirror maze because they got lost and they couldn't get out. So there was just like such a range of things that happened at Sabono. What was your favorite thing we did at Sabono?
Oh, my favorite thing. I can't tell you, actually. You know what I really loved the most was seeing students with that aha experience on their face, which was, wow, I can do this, or wow, I understand this now, or I didn't know that. So for me, I think it was just this feeling that students had their eyes opened to what is available and what is science. Because I think as people, we don't actually think about our world and what's out there, and that it is mostly science. So for me, it was just great watching students get an enjoyment out of it.
So what I tell students in my class, and it's like a fun fact about me as a teacher, is that I strongly believe that science is the real life magic. And they know when they step into my classes, it's like, are you ready for magic today? And then they're like, yeah. And I'm like, yeah, let's go. Let me show you some science. And then that normally gets them super excited. And just thinking like everything you're saying about Sabono, that's exactly it. It's just giving the learners that opportunity to understand that science is like magic and that it's all around us and it's in everything. I mean, they had something that stuck out for me, and it was an eye-opener for me, was the scent section. I don't know if you remember the scent section where you could go up and have different smells, and then you could mix the smells, and then they tell you the science behind how they mix the smells to now get a new smell. And, you know, to me, that isn't something you think about when you think about science. So that was, I agree with you, that just it being an eye-opener and seeing the students just interact with like this real-world experiment that's hands-on and it's there in front of you. And then afterwards we could, as teachers, while we're stepping around, you're like, well, actually, let me explain how this worked. And then I was like, oh, cool, this is awesome. So I think that was also a really, really awesome experience. That, and I mean, to end off Science Week, bringing everyone together after all the fun things we had done, it was just awesome. Now, my favorite thing about Science Week was the virtual labs that we had running. And I mean, those were simulators, everything was done online. And I mean, this comes up to my next question, is that so many people ask me when I tell them I'm a virtual science teacher, they ask me, well, how do you do that? And I feel like what you said now, like with the cabbage, is as a virtual science teacher, I can take your everyday life and show you how science can be conducted with it. Just being able to use kitchen supplies. And I mean, our virtual simulators, all the learners needed to do was log onto a meeting and they could interact with a whole range of things. I mean, I remember we had the orbiter, which the learners loved crashing satellites into Earth and Earth into the sun and seeing how the gravity impacted those forces and just being able to predict the velocity and change it. And it was just absolutely phenomenal. I mean, to chat to my grade 5s about velocity and then they're like, yeah, but what happens if I do this and do that? That was also just something beyond that. And I mean, we had the forces, the friction thing where we had to create a skate park and just the way in which we were able to do that and bring it down, or not down, bring it, that's all, please scratch that bit, to bring it to their level of understanding rather than getting them to try and meet us at our level of understanding. You know, we were just able in this environment to take a really complex concept or complex experiment and break it down to wherever they are at. So whether it be in the kitchen, whether it be in a simulator, whether it be with string and we're doing friction races, everything we are doing, although it's virtual, is more hands-on than I would say I've ever experienced as a teacher in a classroom. What is your opinion on that?
Absolutely. Those simulations are just mind-blowing. So I, in fact, have carried on past Science Week using those simulations, building circuits. So it's very difficult to build a circuit in real life. Nothing ever works. Those wires are always too thick or too thin, or you don't have enough battery power or whatever it is. But those simulations are unbelievable. So particularly with building circuits and putting in all the right potential difference and the resistors and being able to read the potential difference and the current, that has been fantastic. That has been invaluable, those simulations. We wouldn't ever be able to reproduce that in the classroom. So those virtual simulations are just brilliant. And the same applies for electrostatics. So we've carried on with electrostatics with our grade 9s and being able to see what the field looks like. You wouldn't be able to present that in a classroom where you're in person. You just can't present that. It has to be a virtual thing. So that's been just awesome. Brilliant. Those simulations are brilliant.
And what I also found about these online interactive resources is, like you're talking about the circuit one. So I've also used it, not quite at your level. My grade 6s had just learnt about what electricity is, and they are learning all about, what is the difference between a series circuit and a normal circuit and parallel circuit and all the rest. And when I start explaining it to them and they go onto these interactive simulators, the one learner came to me and was like, "So ma'am, my circuit's on fire and I don't know why." And I was like, "Well, thank goodness we're not in a traditional school where we're in class, where my classroom would potentially be on fire." So that's the positive one in this. And I was like, "Okay, well, let's break it down. Why do you think it's on fire?" And they were like, "No, I don't know." And I said, "Well, let's do the process of elimination. Let's start taking out certain parts of your circuit, and if it sets a light while that part is gone, then you know that part's not the issue." And just from being able to do that with knowing that no one's going to get electrocuted, my class is not going to be set alight, the school won't burn down, was just allowing them to really, really explore their curiosity. I feel like from a virtual point of view, it really gives them that opportunity. And I'm not sure about your learners, but my learners were born into this technology age. And I asked them to write something down and let's do the scientific process. And half of them will be like, "So can we do it online? Or can we do it this way? Or can we do it that way?" Because that's how they understand it. That's their world. So being able to bring science and this academia into a world that fits everything that gets them excited about life and gaming and just gamifying it and just allowing their curiosity. I think from my side, I've seen a complete change in my learners since we started introducing all these interactive things and really taking advantage of being a virtual school.
Yeah, definitely. And the simulation with density, which my grade 8s used, the same thing. It's really advanced. It allows them to measure mass. Who has got a measuring apparatus at home to measure that and to measure volume? It was just brilliant. So that was quite an advanced experiment that we did. And grade 8s loved it. They enjoyed it.
So if we had to take a step back and chat a bit about, how do we conduct science in a way that fits in with the curriculum, but also takes it far beyond, while still making sure that we have quality and accurate assessments. How do you get that right in your class?
That is a very interesting question. So you hooked me on the accuracy thing. Well, I mean, the only way that you can be accurate is through the simulations. I mean, there's yeah, for to be really accurate in physics, you need quite advanced equipment, and no school's going to have that. I mean, you probably have like these really ancient, dust-covered pieces of equipment. They actually, I can even smell that. When you sat at those desks that were those wooden desks, those high wooden desks, and it was like a smell about the chemistry lab. Those old pieces of equipment, they're outdated. They aren't used anymore. You need to use things that are electronic, so electronic mass meters and electronic probes and all sorts of things. And I don't really think schools they don't have that available to them because they're expensive. So you have to do an experiment, which is a simulation, to get the accuracy of that. And then, I mean, obviously there are simulations that are good scientifically, but also others that aren't so well grounded in scientific principle. And you just got to choose the correct one. But if you can get data, so the whole thing about science is collecting the data and then doing something with the data. So if you can collect data that is honest and reliable, then you can produce the most amazing results. And that's really what we're trying to do. I think in both the junior phase and the senior phases, you're trying to allow students to get the best possible data so that they can interpret it and problem solve it to the best of their ability. And you're teaching them that progression. So what about thinking about it in this way? Or what else can you do? Like you're saying, what else could you do to find a solution? I don't know if that answers your question.
Somewhat, but I am gonna just build on what you've said there, and that is all about, like, if we had to look at how education is changing and how it's evolving, learners no longer need to remember a whole bunch of facts. They have a walking encyclopedia, or not a walking, a functioning encyclopedia in their pockets. I mean, a cell phone, at any point they have access to a world of information. And this change from, this is the textbook, this is what we need to learn in science, let's move forward with it. I feel our environment allows us to take it so much further than that, where we can say, well, this is the accurate information. What can we do with it? If we were in the real world, and let's say we need to build a circuit, and it sets alight, how are you going to problem solve on what your problem is, and how are you going to fix it? I do believe giving them these simulated environments and, real world things, it does really allow them to understand how science fits into that, and it helps us build up that problem solving, critical thinking in a science manner.
Absolutely. So yeah, so the whole point of, well, for me, for science, is to look at your world critically and to be able to see it, in a different perspective, from a different perspective. And problem solving is definitely a key skill. And those skills are not, they have to be fostered. You have to develop them, and without the burden of knowing stuff, without the burden of being an encyclopedia, you can free up your mind to be more active in the problem solving process. So absolutely, I agree with you.
Oh. No, I love that. And I love that we're able to do that in this environment. I do feel it is a step forward in curriculum development and just in building the learners up, because it's a skill that they won't just use in science. And that's also really exciting when we actually start to build them up as a holistic human being, where everything starts interlinking. And I do think that's just one of our massive benefits of how we deliver education. And then I want to know, did you test your learners or just try and see their insights after Science Week on any of the information? So before you answer, I'm going to give a go in my answer.
Okay.
Otherwise, I will forget. So, I mean, from my side, the grade 6s, they tested friction and they got to see how friction is present on the rope. And then the next week, we actually then put oil on the rope to see, well, does this aid friction or does it take away from friction? And from there, the learners had to go and design their own friction activity. They had to design their own friction investigation. So from that, they could choose all the different types of friction. So they could do air resistance, water resistance, and so on. And like one of the learners, I don't know why it sticks out in my brain, maybe because I love cars, he chose to use like a mini toy car, and he had like a little ramp. And with his ramp, he went to the grass, he went on tiles, he went on the carpet, and he went all over the show. It was, but just the way they thinking on how to test things. And then he was like, so there was lots of friction on the grass. And then a week later, so they had 2 weeks to do it, a week later, he tried it again on cut grass. And he came to the conclusion that when the grass is taller than the car, it's a problem. But when it's the same size as the car still goes somewhat. But just being able to understand how that friction is present in everyday life.
Yeah.
And things like that. I had other learners trying to test friction with water. I had another learner, which was also really interesting. She crumpled up a piece of paper, and then she had just a flat piece of paper. And she dropped them from the same height to show how air resistance would then affect and how the surface area of the actual object would then go, and then she compared it to a parachute. She said, well, if your parachute doesn't open, you got a problem. But if it does open, it's not so much of a problem. And then she went on to tell me that's all about air resistance. And she actually made a really awesome video, which was far beyond my assessment. So the learners, I feel, after Science Week, from my side, were so engaged with the topic that they were so excited to then go and do their own investigation. And I've done it before where we haven't had Science Week, and I'm like, okay, we're going to do investigation now. And they're all like, oh my goodness, I don't know how to do it. I'm not a scientist. Whereas after Science Week, and we had gotten into this frame of mind, and we had a whole bunch of activities, and we really immersed the learners in science. They're like so excited about it, and they believe that they can be scientists. So I call them my future scientists, because I told them if all else fails, please become a scientist so that I can be a proud teacher. But jokes, I'm always proud of them. They're such an awesome bunch. But it just, Science Week for me really just gave that extra oomph, because we had such a focus on science that they just got excited about it. So when it did come to testing and learning and, doing all the normal academic stuff, we could then move forward in a fun manner. And I know my grade 5s, after building rockets for Science Week, then had to go and design a Mars rover that included an extra modification that wasn't currently included in Curiosity or Perseverance or any of the Mars rovers. And like some of the things that I got out of that were absolutely phenomenal. One of them was like, so they had to include samples, they had to include a camera, and then their rover had to do the terrain. But like some of them had a drone that clipped into the Mars rover that was also then solar powered, and it used the same controls as the rover, like things like that. And I'm just trying to think off the top of my head some of the things that were done. But on a whole, I was just really impressed. One of them had a thermometer, and one of them had a wind indicator, because we spoke about how Mars sometimes has dust storms. And they said, yeah, but we need to understand how fast the wind goes, because what if we put up so they talk about it as a bubble, that Elon Musk is going to go and put a bubble on Mars. Just from the design that he's put out, they now think of it as a bubble. And they're like, okay, but we spoke about balloons. And they were like, okay, but if I have a balloon and I blow air on it, it's going to move. So then they were like, but we need to know how much it needs to be able to move. And just things like that. I was thoroughly, thoroughly impressed with the learners. One of the learners, this is the one that I was trying to think of. One of my learners told me that instead, so we must have a solar pack, so solar panels and a battery. And they said, why can the wheels not work like a turbine, so that it then creates that kinetic energy that then can become stored energy? Like, just their way of thinking blew me away. I cannot tell you, I get so excited. And this is all about the excitement, not even about my class. This is about assessment. Like, it really, for me, was just such an awesome time, and being able to test that in a fun way was just really cool. How did you do that in the high school?
So the heart dissection is definitely part of their testing. So I think that when we do come to test that, they will have a much better understanding of the way the heart works and the parts of the heart. So it's not just a drawing, it's something that's real, and they can picture then which part is which. That definitely inspired some of the grade 9s. They were really, really excited about that. And the seniors, you know, they have a quiet excitement. I don't think they're quite as as wild as the smaller kids, but definitely grade 9s. You can see it on their faces. They have this, and they're prepared to chat more and engage in discussion more about it. So they really enjoyed that interaction. It definitely pushed their experience to a new level. So I was happy about that. Our cabbage experiment was great. That was just wonderful. Yes, and it was for marks. So, so taking the experience and then having to present their findings in a scientific write-up is also a skill. Being able to take your data that you've collected, what you've observed, and then place it in a way, or write it in a way that makes sense to the person that's reading it and to yourself is a skill. And I think that many of the grade 7s got that right. And I think that a lot of them were also very excited about that, because they did upset their parents with the smelly cabbage juice. But they also experimented then. I think they realized, okay, well, this is something that we can use, and let's try it on everything. So they went way beyond the number of substances they had to use in the experiment. And they tested like Disprin, and one kid even tested urine. I mean, it was just amazing. I know. So that for me is, wow, we've got someone who is involved, who's interested, and who sees that science is just a greater part of their lives now. So for me, that's the fact that they tested the urine was just, wow, let's just check this out. Let's see what our bodies are doing. And yes, this is a real indicator. It can actually tell us whether something is acidic or alkaline. So that was great. So definitely, you know, in the scope of our experiment, there was testing, and kids did go the extra mile. That was just mind-blowing. I enjoyed that.
Everything you say just comes down to everything we want as teachers. I mean, as teachers, we have such a passion for science and for curiosity and learning, and being able to pass that on to learners. And I mean, in our case, it's not just learners that are in your class, it's learners that are sitting in their homes from around the world. We have students from 21 different countries, and we have this scope to give them this passion we have and pass it on for learning and science. And I don't know about you, but as a mad science teacher, that's everything I want in life. And it does make me feel like there's hope for science in the future. Because, I mean, everything that we look at, if we had to look at how things evolve, technology and, you know, just in general sort of life, it all kind of comes down to science. Inventions come down to science. And being able to be like, hey guys, I love science and I love learning about science and I want more of that. That's all we ever really want as teachers. And I feel like Science Week just really emphasized all of that in all our learners. And I don't know, for me, there's nothing more I want out of life.
It was very exciting, and it definitely pushed many students to think differently, and they had experiences which they would never have had otherwise. And that might have just triggered the spark to be interested and curious. And the curiosity is what we really want. So yes, go and see if you can rot something in your kitchen. You know, see if you can grow some fungus. See what fungus comes out. What color does it come out? You know, as make some penicillin. You know, who knows?
See what fungus grows on. See how many different items you can get fungus to grow on. No joke.
Absolutely.
We have to do, we send our learners to do that. Parents might just hate us.